Hello everybody. I'd just like to first of all say thank you very much to Coeliac UK for having me here today. Just check where the pointer. So I feel in good company as a neuroscientist following up on a talk about multiple sclerosis. Although what I'm going to be focusing on today is much more kind of general question about what gluten does to your brain in people who have forms of gluten sensitivity. And the talk is going to be a little bit of a tour, a bit of an overview of the work which I've been involved in at the University of Sheffield over the past couple of years. This is the part of the brain called the cerebellum, which is all about movement and coordination. And the cerebellum is extremely atrophied in this particular scan. It should essentially fill the entirety of the black space around it. And we call this presentation gluten ataxia. And gluten ataxia is not the only quite kind of blunt presentation that we see in the brain of neurological problems. We're also aware of something we call gluten encephalopathy, which is where these things we call white matter lesions crop up on scans, all these kind of white patches that basically should not be there. And these two kind of pictures, I think, summarize quite nicely the kind of damages which we've come to expect from gluten. On the one hand, we can see involvement in the cerebellum, and this leads to issues of movement, coordination, and sensation. And some of the research we've done at Sheffield over the past few years has been implicating that transglutaminase 6 antibodies might be a potentially useful marker in the blood for patients who are more at risk of having this as an outcome. And on the other hand, we have involvement of kind of higher up in the brain of the white matter, and this leads more to kind of very bad headaches, cognitive problems, and also everyone's favourite term of foggy brain. And the take-home thing we always like to highlight when we're talking about this is that these often happen in the complete absence of any gut symptoms and happen as pure neurological cases, although in some cases gut symptoms are also implicated to some degree when you kind of dig into it and ask the patient. So something I'd like to kind of recontextualise quite quickly straight away is of gluten sensitivity as being a multi-system problem. Of course, we know it can affect the gut, we also know it can affect the brain, and not to leave out dermatitis herpetiformis, we know that it can affect the skin also. But rather than doing these things in sort of true isolation of each other, what we tend to see more is that it happens on a bit of a spectrum, and that it might have a predominant focus on one of these outcomes, but when you kind of look a bit deeper, we find that there is involvement of the other systems as well. And of course, just to ground us all, what we call celiac disease is not only very focused on the gut involvement, but it's when the gut involvement is quite severe and we get that characteristic enteropathy. So the pictures I've shown you so far clearly are of quite kind of severe and notable presentations. What I'm actually going to be focusing on today is more asking the question, how pervasive are neurological problems across the whole spectrum of gluten sensitivity? So I'm going to be trying to dig more into what we would call kind of typical presentations of celiac disease and also non-celiac gluten sensitivity, and digging into that to see what kind of neurological problems that we find. So starting out with celiac disease, this slightly busy slide kind of summarises everything that we currently know about the brain's involvement in celiac disease. So we know that in patients who have neurological referrals, there are balance disturbances, headaches, sensory systems. We know that they have increased white matter lesions and brain atrophy compared to controls, which fits in quite nicely, of course, with the kind of presentation that I've already shown you in those slides at the start. We also know a scattering of other things as well, like there's an increased risk of vascular dementia in celiac disease, there's some signs of blood flow alterations, changes to the white matter's microstructure, and also cognitive impairment compared to controls. So I think this is a very good kind of foundation which has been made, but there is overall, at least I think, a real kind of lack of literature and studies which have been done into this topic. I think understandably the foundations have been made a lot in patients who happen to have neurological referrals, which makes sense, but I'd like to try and move the research on to looking at more kind of typical presentations to see how generalizable these kind of findings are. And also from my own point of view, because neuroimaging is kind of my tool, my trade, there's a lot of key MRI methods which haven't yet been implemented in any of this research, which I'm keen to look at, because I think it might tell us more about the topic. So the first experiment I'm going to give an overview of is one that was funded by Coeliac UK a few years ago in a grant given to Marios Hadjivassiliou. And we consecutively recruited 100 newly diagnosed celiac disease patients with a typical sort of referral pattern who didn't have any otherwise history of neurological problems. And the objective of this really was just to try and characterise the neurological problems that they had in this cohort. So all subjects underwent a clinical neurological examination. We did blood testing for transglutaminase 6, which, as I've already said, we think might be a marker of people who are more at risk of harms in the brain. And we did MRI scanning of the brain, including structural scans and a kind of spectroscopy scan, which is something which lets us look at the biochemistry of the brain. So the results of those examinations, 10% of these patients showed signs of peripheral neuropathy, which are kind of sensory problems. 29% had some level of difficulty walking, and 11% had nystagmus, which is like an eye twitch kind of movement disorder, which is quite a hard kind of neurological sign. And in terms of what they self-reported, 24% balance problems, 42% frequent headaches, and 12% sensory symptoms. And if we ignore headaches, because everybody gets headaches, we still find that 50%, exactly half of this population, still had some sign or symptom of neurological dysfunction. Remember, these are your typical celiac disease patients at the earliest point in their clinical history. This is at the time of diagnosis, and this is already a kind of a prevalent problem. And this idea of kind of half of them having an issue was backed up by what we found in the spectroscopy. The reason we do spectroscopy is because we can measure something in the brain called N-acetyl aspartate, which is written up here as NAA/CR. And we measure that because we know that levels of this metabolite are depressed in people who have gluten ataxia. We have clinical cutoff points where if it falls below that, we consider the levels to be abnormal. And we're measuring the levels of this from the cerebellum. And we find, again, that about half of these patients had abnormal NAA values, and sure enough, in the majority of those was in the vermis, which is the region where we most find issues in gluten ataxia. So I then did some image analysis on this group, did some brain volumetry, which, as the name implies, involves taking measurements of different volumes of different brain structures to compare them between groups. I did this in two regions. I did it in the subcortical grey matter, which are these kind of like lit up regions here. I also did it in the cerebellar grey matter as well, over on this side. And in each case, I took the entire grey matter volume across all the subcortical regions and all the cerebellar ones, but I could also look individually at the kind of the subanatomy and the subregions within it. And the reason I was doing this was because I was wanting to ask the question if TG6 positivity predicted that there might be any atrophy in these regions in these newly diagnosed patients. So 40% of the patients had transglutaminase 6, and sure enough, there was an overall effect in both the subcortical grey matter and the cerebellar grey matter of atrophy. In those who had TG6 positivity, they had a tendency to have lower brain volume in these regions. Now, when I digged deeper into the cerebellum, I found that this was more of a general effect across the whole cerebellum rather than driven by a particular subregion. But in the subcortical grey matter, I found that this was mainly driven by a reduction in volume of a part of the brain called the thalamus. This is the thalamus. It's the green region from this picture I showed you earlier, or from this handy GIF which I nicked from Wikipedia, also shows quite nicely where in the brain it is. So I then did kind of a subsequent analysis where I kind of made a 3D model of the thalamus, and I was able to project onto that to see where exactly in the thalamus the atrophy is occurring between these two groups. And this is the result of this kind of green blob. This is an image of the left thalamus, and similar results were found in the right-hand one as well. And we found that the sites of atrophy are these kind of orange regions on the top and on the bottom. And if we try and match that up to what we know about the subanatomy of the thalamus, which starts getting into sort of real sort of picky levels of literature, but I kind of found it matches up quite nicely to these ventral and lateral regions, which are sort of shown by these purple boxes here. And the function of these parts of the thalamus is that they project to regions of the brain to do with motor and sensation. So this ties in, of course, quite nicely with the symptoms we come to expect. And it further makes sense when we consider that what the thalamus is doing here is that on the bottom of it, it is accepting inputs coming up from the cerebellum, and then at the top, it projects those inputs out to the rest of the brain to kind of process and control these functions. So we're starting to see a nice kind of pattern emerging of sort of, regular pathology in the cerebellum, areas the cerebellum projects to, and then the kind of symptoms we'd expect are happening from damage to these regions. So the next experiment I'm going to give a quick overview of is one which I think is quite complementary to this. It's using information from the UK Biobank And I should say that this analysis which I'm doing is in progress at the moment, so these are kind of little previews in a watch this space sort of moment. For anyone who's not aware, the UK Biobank is a massive health resource funded by the Wellcome Trust. It's a huge initiative. They recruited 500,000 people and collected a very eclectic set of research data that is available if you make an application. And more recently, they've begun a monumental task to perform brain MRI scanning on 100,000 of those people, which is still ongoing at the moment, but they've got about 30,000 of those scanned, and that data is currently available. So I made an application to the Biobank, and from this, I found that there were 89 subjects with celiac disease who also had brain imaging, who also didn't have any other confounding neurological conditions or problems and weren't on any problem medications and things like this. And I was able to match those to controls also from the Biobank on age, sex, highest level of education, body mass index, and if they had a diagnosis of hypertension or not. And the point of all this was I wanted to do a series of case control analyses to look in quite a broad way, because of course the previous, what we were looking at, were kind of within subject comparisons, so I was wanting to look now comparing what we can reasonably assume to be typical celiac disease patients to the general population. So the first result from this was I looked at some cognitive and sort of mood data, and these are all very kind of hot off the press over the last month, essentially. We've found so far that reaction time is significantly slower in the celiac disease volunteers in controls. And also, there are these statements which kind of ask questions about mood, for sort of anxiety and depression, which we know has been implicated in some celiac disease literature. We found that the celiac subjects had a tendency to say yes far more often to questions implying that they might have heightened sort of issues around anxiety and depression. And then the other part I'm going to show you from this analysis, getting into this imaging, which I keep going on about, is something called diffusion tensor imaging. And this is an advanced kind of MRI scan we can do. It's based on the movement of water molecules in the brain, which sounds quite abstract, but from that we can get very accurate and good information about the brain's microstructure. And it's very sensitive at picking up damage between populations where you can't normally see damage in conventional MRI scans, which is why we're interested in using it here. And sure enough, in this, we've found regions throughout the brain's white matter tracts of damage in the celiac groups. This is mainly focused around the brainstem, which of course is the part of the brain which moves up from the cerebellum. It goes up through the thalamus as well, where we're also getting significant results, and then projects out to the top of the brain. So again, I think this is adding on that kind of connection between the cerebellum and the thalamus, and all of this is hopefully coming together quite nicely so far. So for the final part of the talk, I'm going to move on to everyone's other favourite topic, non-celiac gluten sensitivity. Just to ground everyone here, the definition of this, which I am using, again, is what I believe to be the kind of a typical interpretation of it, which are people who self-report issues to do with gluten after they eat it, but when they are put through the referral process, they are found to not have celiac disease on clinical examination, and they are left with this diagnosis. And the reason we're interested is because, again, like in celiac disease, neurological symptoms are indicated. There's very little research that is done into this topic, but from the papers we can see that headaches are quite prevalent, and confusion there is quite a hard term, brain fog, less of a kind of a harsh term, but we can still see the kind of the patterns emerging here. And working at Sheffield with people such as Professor Sanders, who of course has been running a celiac clinic for many years, we've got access essentially to a database of a number of patients who have been treated and have been found to have non-celiac gluten sensitivity after their investigations. So we sent out a postal survey to them. We approached 221 such people, and 118 responded. And the survey tools we put in were there to characterise their dietary adherence and also their quality of life, and that's from something called the Celiac Symptom Index. So it's quality of life in a way which is particularly focused on the problems we expect to see in celiac disease. We also asked some bespoke questions to characterise the frequency and severity of their neurological symptoms and also their sleep quality. What we found from this was that of the responders, 43% described their diet as one where they attempt to eliminate gluten completely, and 17% actually said that they made no restriction at all, which, that's obviously not nothing, that's a fair chunk of people, but I think, we would probably expect in a celiac disease population that the numbers on kind of strict gluten-free diets would be a bit higher than that. Nonetheless, more than that percentage reported still that they had a reaction every time that they ate gluten, and the median symptom onset time was 90 minutes with resolution at 48 hours. And concerning those symptoms, neurological ones were common. I think we got some of the highest kind of reported numbers which I've seen in the literature. Headaches in over half, brain fog in almost half, then balance problems in a third, and sensory problems in a fifth. So again, we're having this kind of repetition of these similar problems across all of gluten sensitivity. And I know that the dietary adherence there was maybe a little bit deflating because it wasn't particularly high, but we found extremely significant relationships linking together dietary adherence with their quality of life outcomes, both always in the direction of poorer adherence leading to a poorer outcome. So I think this potentially raises, my point of view on this is that maybe there's a bit of an issue around kind of the language which we're using when we're defining these patients. Clearly they might not be taking the condition maybe as seriously, there might be a lot of uncertainty in their mind over the real kind of significance of it, but when you actually look across the whole population, and I know that this group is sometimes a subject of some controversy, we still see these quite strong effects that show that diet does appear to be very important to their quality of life. And of course, the last thing I was wanting to do, I was wanting to ask what about brain imaging. So we performed a little pilot study where we invited 5 people who responded to the survey in to do some brain imaging. Brain imaging has never been performed before in typical non-celiac gluten sensitivity subjects, so this was largely just to try and characterise any sort of signs of damage which has happened. These people were all on strict gluten-free diets. They all said that their symptoms worsened by more than 30% after they ate gluten to fit in with the Salerno expert criteria. And they all reported brain fog as a symptom as well. So the brain imaging largely looks at white matter pathology, and these are going to be sort of similar to what you've maybe seen so far. So what we're interested in here are these little white dots, which are much less severe versions of those big white matter lesions we saw in the first scan, but these are still worrying. These are things which do happen with normal healthy aging, but they can still happen above and beyond what you would expect for somebody at a certain point in their life who don't otherwise have any indications for them, as all of these patients do not. So first of all, this 34-year-old has 3 punctate lesions, we call them on this scan, which is more than you would hope for somebody at that age. This person is much older, 69, but all the same, this is quite a pathological looking brain. There's a lot of punctate lesions going on, and some regions, such as up here, they're kind of moving from punctate lesions to what we call more kind of confluent sort of presentation, which is what we start to expect in things like multiple sclerosis or more sort of dementia type conditions. And then finally, another quite young person who, high up in the brain here, had this one quite pronounced white matter lesion, and this person also had a couple more further down in the brain as well. So this kind of white matter pathology potentially seems indicated as well. And then the last thing which I'm going to show you from this pilot study, we also did a little sort of exploratory test where we scanned their brain as they've been on a gluten-free diet. Then we also fed them the poisoned gluten sandwich. And then we scanned their brain again afterwards. And the objective of that was to try and see if we could detect any differences in blood flow before and after. I should say straight away, in 4 of them, it's a flat line. There's no effect. So we're taking this result with a lot of caution. But I still thought it was provisionally interesting to show here, because in one subject, we found that after they had gluten, blood flow seemed to increase by a level of 14% across all of the grey matter. So like I say, this really is an N of 1, but provisionally still something interesting going on there, which we'd like to look into a bit more. So coming to the end of the talk, just to tie it all together, at one end of the gluten spectrum, we've got our blunt neurological presentations of ataxia and encephalopathy. And from here, we expect to see cerebellar atrophy and white matter lesions, and this leads to issues of movement, sensation, and cognition. There's potentially a sign that transglutaminase 6 is somewhat involved in the pathophysiology of this. If we look at our typical presentation of celiac disease, neurological signs are prevalent. Half of newly diagnosed celiac disease patients have issues of movement and sensation. We also find cognition and mood problems. We find that TG6 positivity predicts cerebellar atrophy in this group, and also atrophy of the thalamus, which the cerebellum projects to. And the cerebellum projects to the thalamus via the brainstem, which shows altered microstructure when we look on a diffusion tensor imaging scan. And then finally, if we look at typical non-celiac gluten sensitivity, which I know is a controversial group, and just to also get to the core question of the day of who is a gluten-free diet really for, who does it benefit, sometimes people aren't entirely sure here, but we've found evidence, at least in this cohort, that dietary adherence is important and does benefit these non-celiac gluten sensitivity patients because it was significantly linked to quality of life and sleep. Again, neurological signs of the same sort of ilk are common, and we found some initial indications that white matter lesions are also there. And the kind of final thought which I'd like to end on is just that in a way, the non-celiac and the celiac subjects are kind of the lucky ones, because they're the ones who get gut problems, and they get to go to doctors, and doctors know that gut problems are to do with gluten, so they get the referrals and they get the tests, and then they're told a gluten-free diet will be good for you. They have that opportunity. The ones who have the pure gluten sensitivity don't get that telltale sign to help them along the way. And we see them present about a decade later than celiac disease patients do. And it's kind of our personal hypothesis that they might be developing the sensitivity to gluten at the same time, but because they're not getting told to go on a gluten-free diet, this brain damage is just accumulating until it becomes a real neurological problem. And if these celiac subjects weren't getting told to go on a gluten-free diet, 10 years down the line, they might wind up looking something a bit more like the severity which we see over here. So thank you very much, everybody, for listening. So thank you also to the collaborators and to Coeliac UK and the Brett Trust for funding a lot of the work which I've gone over here. Thank you.